Hi, this is the teacher video for Lunar Lander. You should be sure to watch the two student videos first and try landing a few times so that you understand the game basics. In this video, I want to show you some cool aspects of the data analysis environment and go over some issues with how students invent a score for the game. Let's begin with the table. We've already made 3 landing attempts. Data about each landing attempt appears here on the left side of the table. On the right side, we have information about individual moments of time within each landing. I can click on this minus sign here and collapse all that. Now I can see 3 flight records and use a plus sign to expand the second record individually. The data is organized hierarchically. That is, you can think of all these moments as being inside the landing attempt. So if I click on the left and select the landing attempt, in this case the second one, all of the points are selected on the graph. But if I select an individual case on the right-hand side, I see only that moment selected on the graph. Let's learn more about the graph. To change what I'm plotting on the graph, I click on the axis label. When I do that, I first get a menu where I choose what level of the hierarchy I want to look at. So if I want to look at the flight record, the individual moments, I could, for example, change from altitude, which is what I've got now, to speed. And that will give me an interesting graph of speed versus time. The other way to do this is simply to drag the column heading to the axis. Dragging altitude back to the vertical axis puts the graph back the way it was. You can also drag to the middle of the graph. Suppose I drag attempt number. Now I can see which landing is which. Or I could drag in speed, and now I can see that the fastest I ever went was here in the middle of this flight. We call these middle of the graph attributes legend attributes. You can remove them here in the gear menu. I can make more than one graph too. Here, I'll plot data about landing attempts, changing the horizontal axis to impact and the vertical to total time. Now I have 1 point per landing rather than 1 point per moment. And if I select, I see the corresponding flight record in the other graph. So let's talk about the score. The key question is, how do you know how good a landing is? What makes one landing better than the other? And we want to make that judgment quantitative. One place to start is the graph. Ask, which one is the best landing? In this case, it's pretty clear that the first one, which I've just selected, is the worst. It's diving into the moon. But how to decide between the second and the third? The second landing is quicker, but has a higher impact. Students will figure out that the 3 main issues are impact, time, and fuel, which are also the 3 numbers that show up in these gauges and also appear in the landing attempts table. The challenge is to create a formula that combines these to make a score that everyone agrees is a fair way to evaluate a landing. If students have trouble coming up with sensible formulas, you can ask them questions such as, all other things being equal, do you want a large impact or a small impact? Do you want a long time or a short time? Do you want a lot of fuel left or a little fuel left? People agree that you want as little impact as you can get, a short amount of time, and to have as much fuel left as possible. Then the question is, how do you combine those 3 variables into a single score? The 2 simplest ways to do this are using division or using subtraction. Either way will work, and either way shows that students have some understanding of how the mathematics works. As you've seen in the second student video, they'll make their formula as a new attribute in landing attempts. They'll get a box in which they enter the formula for the score. This formula still gives the bad landing a high score. When this happens to students, ask them why. And this will lead them to the next level, which is to tune that formula, for example, using different coefficients, so that it reflects what they actually believe. Then it's important to have students play against one another using 2 landers, so that they can essentially have a one-on-one contest and see whose formula picks the landing that they actually think was better. Good luck!